February 27th here for another Professional Evil webcast. Today I'm joined by Doug Bigalke and Alex Rodriguez. We're going to be talking about some fun that we did and solving a problem that we had with our own cracking server. So as I said, with me I have Doug and Alex. Doug, while he's not out there helping us get Jacksonville and everything running, he's really a 3D printing wizard. He's like the Jedi of filament, droid whisperer. He is able to make practically anything you want out of a 3D printer. It's not just little keychains. He makes full articulated dragons and droids from Star Wars itself, some of them moving. And then, of course, if the bots begin to get rowdy, he just makes them enter the BattleBot arena on his spare time. And then we also have Alex. He's our Linux-loving, automation-obsessed, state-hopping, state-moving security guy. When he's not building automation for everything, including his coffee in the morning, he's diving headfirst into Linux commands. I can't talk today, like they're his favorite bedtime stories. But besides all of that, once again, when they're not having fun, they're both incredibly talented and knowledgeable at hardware, operating systems, and applications. They were perfectly suited to help us solve a problem, and that's what you're here to talk about, right?
Yes, that is exactly what we're here to talk about.
Perfect. So I'll just kind of hand it off to you so you can cover what we had with our cracking servers.
So as Eric has already introduced us, we'll skip that slide.
But I did the fun introduction. You
did the fun introduction, serious. But the dry introduction is not as fun.
Okay.
So, as we try to test things, we find hashes that need to be cracked, and doing it on someone's laptop is not prudent for a test at all. So many years ago at this point, we built a cracking server, and we got it running and working, and 2020 came along, and we decided we needed 2 more. So we went along and started building those 2. One is called red, one is called blue, because we put LED fans in them to keep them separate. I know Alex was involved in some of the sourcing of some of those parts. Do you want to talk about some of that fun that we had sourcing?
Well, we had the brilliant idea of doing that while there was a GPU shortage. So sourcing graphics cards was less than optimal at best. And we ended up having to, I think at the time it was around the 2000 series graphics cards. And we were still kind of stuck with like the 1000. So we ended up getting the 1080 Ti's whenever we did graphics cards. So that was probably some of the most difficult sourcing. I think Nathan, if I remember correctly, had found it on like Facebook Marketplace or something like that. Or was that the
No, that was someone found locally the server racks locally on Facebook Marketplace. So the big server rack that we had was found locally, and we had to go pick it up in my trailer that I take R2D2 around in, which was fun.
Yeah. But yeah, it was a drastic improvement from the previous cracking server that we had, because there was one time where Doug and I were sitting on a Google Meet, and he had his camera showing his phone the different BIOS options that we could choose and stuff. So
yeah, because we didn't have remote access into that for Alex to troubleshoot. I remember because that server ended up losing one of the PCIe lanes.
Yeah.
So we only have 3 on that server to run GPUs on it, which was frustrating because we couldn't figure out why for the longest time.
Exactly.
So when we were looking at this, obviously we had a budget because we are not a giant corporation. I did put together some numbers here that if we had a off-the-shelf server, they started about $30,000, and those are some pretty crazy prices. But I'd like to run some hashes against one of those ones just to see the benchmark of the 48 gigabyte GPU.
Well, and the ironic thing is too is that the RTX or non-GTX graphics cards aren't as optimized for Hashcat, which at least that's my understanding from the Hashcat forums that I saw. So like the things that are more built for like AI and machine learning, they aren't as geared towards as heavy computation as Hashcat does. So like even if we got a server just off the shelf that's like already pre-built, typically they're geared more towards ML stuff. So that's not going to be as powerful as it could be compared to using the GTX cards.
Yeah, I would just like to see the comparison to our little budget setup. We actually did talk about trying to do it maybe in the cloud as an option, but looking at the prices, $35 an hour for cracking, and we've had jobs run for a week or so nonstop. That would be really prohibitive for consulting. We'd have to charge that separately.
Yeah. Well, and the other thing was too is that kind of speaking from the off the shelf perspective and blending kind of like a potential best of both worlds, there was actually a company that is now unfortunately no longer around called TeraHash that they would build purpose-built cracking servers. So it's almost like you get what the cloud vendors would provide, but just off the shelf. But their minimum base price was starting at, I think it was like 16 or 18,000. So that still just wasn't an option in general, even if we were to try and make it more official, but using server builds.
So we decided to build our own, and the picture that we see in the slide here is actually all the components we used to build it with. We have some fans that sit over the top of them that are just there to keep cool air flowing over them, and all the other fun parts to put it together. What did we spend on this about? With the racks, we were at about $12,000 for both of them.
Yeah, total, I think it was around 5,000, so around 11,000 overall.
Okay.
Specifically, it was like 5,000, almost 6,000 for each server, but we got two servers out of this instead of a single server.
Yes, and I'm also including the racks that we bought and the rails and all that stuff, because we wanted to put them somewhere that we'd have better control over them, because the other one just sat on a table. The old gray one just sat on a table somewhere in the corner of our supply room here at the office, because we didn't have a dedicated server room. We do most of our stuff. These are actually the only physical servers that we have in the company. Everything else is done in the cloud, is these cracking servers. So we were not set up necessarily in this office for that. In fact, we had to have power pulled because they each have 220 volt power supplies. So we had to have that pulled too while we were putting this together. The old cracking server is only running at 120, but that had to have the power supply replaced at 1.2 in its age.
Yeah, and that was one of the things we ended up facing was anyone that tries to do even more computationally complex GPUs, like newer generations of GPUs, they're going to have to really think hard about their power situation because those GPUs draw a lot more power. So we had to take that into consideration for where we could install it, as well as the power supply itself.
Yeah, we still have to, because we don't have a dedicated server room. We do struggle sometimes with cooling. Just ambient air is what we have besides all the fans. We'll get more into that when we get into our cooling section of talking about some of the struggles and things that we had to deal with when building this. So that's the same slide, but backwards. There we go. Let's talk about hardware. This is what we ended up choosing for our build. Now these prices are from 2020, so they're a little old. I'm sure we can get these exact boards for a little cheaper. GPUs.
Yeah. Well, and specifically this board was because it had so many PCIe lanes. So if you look at that bottom right picture, you can see it's got space for, I think it's seven PCIe slots. I mean, this server doesn't fit 7 GPUs like directly next to each other because they're full width slots instead of a single slot. But that was
We were able
really
to put-
the main draws.
Yeah, we could put four GPUs in there and have them side by side by side.
Exactly. That, and we had IPMI.
Yes, which has saved us in many instances where Alex, being in at the time Carolinas, could do a lot more troubleshooting outside of me being here from time to time. So.
Well, and I was able to do all of the benchmarking by myself as well because I could completely reload the base OS without having to have someone plug in a USB drive and step through the installation. We had to do that
in the first cracking server, didn't we?
Yes.
At one point, yes.
Yes, that was the other reason why I was on Google Meet, was that as well. I think I had made a guide for most of it, but then there were a few things that it just wasn't working or something like that. So,
yeah.
But the other really important factor that we chose specifically about the processor is the amount of PCIe lanes that the processor supports. So if I remember correctly, this AMD EPYC processor supports up to 128 PCIe lanes. So that is, it blows Intel out of the water for a single processor, at least at the time it did. Blew Intel out of the water for how many PCIe lanes a single processor could support. So if we were to even try and replicate this on Intel build, we had to, at minimum, get 2 processors just to be able to support as many PCIe lanes that we wanted. So that was another reason why we went with AMD and EPYC as well.
For those of people who are watching, why do you want the more PCIe lanes, right? PCIe lanes.
Good question. Yes. So the graphics cards, I think each of them take 8 PCIe lanes for full throughput, for being able to actually get as much data as you can directly to the GPUs. So if you don't want your motherboard or your processing speed to be inhibited by the amount of traffic that's getting sent between your graphics card and your CPU, then you want to try and have full support for all of the PCIe lanes that the graphics card can support. You always, well, from my understanding, you can always install a GPU that has more PCIe lanes into a less PCIe lane slot, but you're not going to get full performance out of it. So your actual cracking quality is going to be degraded. So
cool.
Yes, exactly what Mr. Widget said. It's about the quality,
Cool.
not the quantity.
So then we're going to move on to talking about the powerhouse of cracking is the GPUs. As Alex alluded to earlier, at the time, it was the end of 2020 that we were sourcing all this stuff, and because of the pandemic and everything, everyone was buying GPUs to start mining and machine learning, and so we were limited in what we could buy at the time and source. Also, because of the prices, we had to find a budget which that fit. So this is what we had in our original cracking server, correct? Yeah.
For the graphics cards?
Gray has these same GPUs.
No, it actually still has 980s.
Oh, does it? Okay.
Yeah. They were so hard to source in the first place, we could barely supply the amount that we needed for the actual the rigs we were building. So it's definitely something that we're going to consider, and we're actually in the process of revamping the older server, which is we keep referring to as gray, because the other one is red and blue. So we thought gray because it's older.
And it doesn't light up.
That too. But yeah, so it still actually has 980s. And to answer Keith's question, yes, they go up to by 16 on the server, not by 8. So by 16 gets you that full speed instead of the by 8. There's actually, and Doug, you'll have to speak to this one, there's actually a little piece of hardware that you have to move for jumpers to change how the motherboard works to support the full 16 slots.
Yeah, I don't remember exactly what we had to do to get that to work. But you're right, it was a jumper somewhere on the motherboard that we had to move.
Yeah.
So because Alex is not around, we keep alluding to the fact that I did a lot of me and another consultant, Travis, did a lot of the actual building, the physical building of the servers here in Jacksonville, while Alex supported us remotely. We also, when I built it, we also did a time lapse, which if you saw the social media posts promoting this webinar, I was really happy to build that. I thought it was a really cool time lapse. So I built one as a practice. I think I built blue first, so I could knew all the steps, and I went along and built it with a time lapse. We had a rig with a camera above the server, and that was a lot of fun. I think it's on the Instagram or our Twitter as the link to the time lapse.
I'll find it and post it here. Go ahead.
Yeah. So we should have included that, but also I was looking at the notes for our build. Is the 280s? Some of them didn't have fans, or the 2080 Ti's didn't have fans in some of them, which is why we went with the blowers.
Oh, so that's one thing that if you go to build GPUs in general, and we mentioned in a blog post that we're going to have coming out soon, there's actually a difference based on the type of GPUs you can get, or that you should get. You can always get whatever GPUs you want, but whatever's going to be the most performant for your actual building and keep things as cool as possible is whenever you choose a GPU, you want what's called a blower style GPU instead of what's called an axle fan GPU. And axle fan GPUs typically end up having like 3 fans that are actually looking or like on the card itself. And what happens is that it actually sucks air and blows it out into your case with the axle style versus the blower style. It sucks air in and blows it outside of your case. And so the way that the blower style ends up working is that it takes essentially the heat that your GPU is having and it passes through your case instead of inside of your case. So that way it keeps the airflow a lot more optimized. And the Hashcat forums talked about making sure that you always have the blower style, which is always a lot more difficult to get because it's a lot cheaper to make the axle style, from my understanding. And so like 95% of GPUs out there, you're going to end up seeing the axle style, and you need to always make sure that you end up trying to search for blower style type of GPUs whenever you do this. So yeah, that was a good point.
Which that blower style also allowed us to put them side by side and minimize some of that and keep the air moving through the back of the case when we finally did get it built. Speaking of cooling is something we've been fighting with since day one because they are so heat intensive. There are so many fans on this thing. When it cycles up, it's pretty. They're not as loud as the gray one used to be. The gray one, you would hear it cycle up, and you'd have to close the door in another room. So we've got on the case, we've got 2 fans in the front that are pulling air in, 2 fans on the top which are blowing down. Each of the GPUs has got the blower style fan. The fans on the back, which are probably too small for what we're doing. We probably didn't look at that right. And then you got 2 fans on the CPU cooler. So there's a lot of air moving around. We have also fans blowing over each one of the top of the cases with a thermostat on them that we keep track of the air that's coming out of the back ends of the GPUs. And those can get pretty hot when you see, I think we have a job running right now where we have 146 degree Fahrenheit air blowing out the back of the fans right now. That's the exhaust temperature of the GPUs. So trying to manage that has been problematic.
Yeah. Well, and the thing too, we specifically, that top item that's listed under cooling, that aqua cooler or aqua computer, aqua, whatever the heck, that's actually a fan controller that we got in addition to all of the fans themselves. So that way we could keep track of that and make sure that they're spinning at higher temperatures. And it actually has a lot more advanced features to where like you can set temperature threshold for things, and you can configure based on whatever temperature your sensor is reading, it kicks up to a higher speed or whatever.
Yeah.
There's actually a joke whenever they were building the first Gray computer or the Gray cracking server. Apparently, the consultant that was building the cracking server actually was trying to tune the fans, because he actually ended up having to source it from Germany because it was not very easy to find in the States and stuff at the time. And so he was apparently tuning the fans, and it was taking a while to do that because it was a very manual and tedious process whenever he didn't have like an external remote to modify things. And so while that was happening, he had mentioned earlier, a few months earlier, that apparently I think it was the motherboard came with a copy of Tomb Raider. And so people kept saying that the cracking server build was taking so long because he was benchmarking the cracking server with Tomb Raider. Enjoying playing Tomb Raider.
So the performance degradation question about heat, Hashcat will stop running if it hits a certain temperature. I think it's 90 degrees Celsius if the GPU temperature gets that high. And it doesn't happen very often. It's usually when you're really throwing complex hashes at it that we've had that happen, which is a sign that we're probably not going to get where we want to get with it. We have taken one of the servers recently, and we've taken PCIe extenders and taken the GPUs, 2 of the GPUs up out of the case to allow more air movement around them to try to bring that temperature down and have it run longer. We have not been able to bench that yet, have we, Alex?
No, not yet.
So we're trying taking it from a case where we had pressurized air flowing through, and now we're going to take them out so that we can more have an open case design, because some cracking servers do that. They'll just have the GPUs out in the ambient air to help.
Yeah, that's cooling in this situation, because we didn't opt for something that was more expensive for like a motherboard case, which the motherboard cases started out at, I think, like 1,500 just by themselves because of how many GPUs we needed to be able to support. It was just pretty much out of the question for cost. But to get full server grade airflow, if you're really needing it to eke out 100% and not having issues with cooling or anything, that would be ideally what you could do. But because this is more of a thrift store build, we went for this case that could just handle everything, and then we're trying to work around the air issues.
Yeah. For the most part, cooling's more of it hasn't really been a game stopper, but it's been one of those frustrating things where we want to solve it because we can get more out of it. Because
Yeah.
you're right, the performance hit when it's hot is not ideal.
Yeah. And speaking about what Keith had asked about, can you add water blocks to them? In the Hashcat forums, they kept talking about, or there was multiple people that would say, water cooling doing this makes it a lot more difficult. Because it's not just adding water, but it's also making sure that you're siphoning off the water correctly and putting that into different places. I haven't done any water cooling like that before, but from the way they described it, is that water cooling is a lot more of a headache than being able to just use actual fans to do this.
So I've done water cooling on a computer before, and I bought an all-in-one setup which had the radiator and all the piping already done. And it ran really well for about 6 years, and eventually the antifreeze evaporated to the point where it wasn't circulating enough. And I only ran it on the CPU. Putting it on the GPUs would probably be very difficult, and that's where most of our heat's coming from, because the GPUs already have a fan case around them with the blower style and channels. To get to the actual chip to put water blocks on them would be... We couldn't do it in our case the way it was. We'd have to do open air to get that to work.
Yeah, for the density, and then in general, it's not just adding water, like he was saying, to the CPUs. You'd have to be adding the blocks directly onto the GPUs, which they weren't built to do that by themselves, like standalone. So,
and most of the temperatures we look at, we're not looking at the CPU temp, we're looking at the GPU temps. They're not super accurate, but we have the fan controller actually has temperature sensors, which we've attached to the back of each of the GPU boards where the actual chip sits, and we're monitoring that temperature from a fan perspective to see what those temperatures are and what the output is, and that's how the fan adjusts. The fan controller is adjusting things based on the GPU temperature that we can get. Because everything's all in one and built, we can't put it directly on the chip, so it's on the other side of the silicone, but it's accurate enough that we can see which the two in the middle are always hotter than the ones on the end. But that does tell us, the fans at least, good data to change that cooling.
yeah. Cool. Do we want to...
So that covers, I believe, most of the hardware, unless there's any other questions about hardware. We're going to get into the software side of our build. And this is where Alex is going to shine.
Yeah, I do most of the operating system management, and in this particular case, I didn't mean that pun. Dealing with the old cracking server that we had a particular issue with GPU drivers, and we were doing everything just straight on the operating system itself. And so because GPU driver upgrades sometimes weren't optimized for the kernel yet, or whatever issues NVIDIA ran into with the actual Kali install that we had on there, periodically the system would just seize or just power off. Something would happen to where we'd have to have Doug actually go down there and power cycle the server.
There may have been many jokes about the fact that it was one of the reasons I was here, was just to go and power cycle the cracking server. Is Doug in the office?
Yes. Yeah, there was, before I redid how the cracking server worked, that was happening quite often, probably once or twice every 2 months. So it was starting to get in the way of consultants being able to do their job, which was not good. And so one of the things I ended up doing was, essentially I had to take into account, how could I make the actual server stability be better? So that way it wouldn't drop off of our VPN all the time, because it was paramount that we needed to have access to it. So we could get consultants continuing to crack their client hashes and stuff like that. So how do we recover if the system does fail? That's where the IPMI came in. And how do we handle being able to do Kali upgrades and driver upgrades? And I'll talk more about this later, but essentially lots of people recommended at the time for running Ubuntu for the actual OS for that you do cracking on. But we found that after a certain period, Kali has actually gotten a lot better at being able to support cracking, because they published a blog about, hey, this is how you use Kali to crack password hashes in the cloud. And ever since then, if you follow that blog guide, you end up having a really good experience using Kali to actually crack hashes instead of having to manual NVIDIA upgrades yourselves. You just use the ones that are in the repository. So the answer was virtual machines, which is kind of unintuitive. Typically, you wouldn't think that you'd be able to do password cracking inside of a virtual machine. But the Linux kernel actually has a really awesome feature that's called PCIe pass-through. And it's actually used by a lot of the actual cloud providers themselves. So libvirt, KVM, that, and QEMU, I'm just going to call it the libvirt stack from now on. But they use those underlying technologies to actually take physical cards, or however they slice it up, and they pass through the GPUs into those VMs. So that's kind of where the origins of where I thought about, well, hey, if the cloud providers can do it, why can't we? And whenever I thought about that, I also thought about, for myself, I'm actually a Linux user for my bare metal operating system. And so whenever I wanted to play play video games on Linux, I wasn't having the best time of experiences, because it was less than optimal. Apparently, it's supposed to be a lot better now. I still haven't fully migrated, but you can do PCIe pass-through to a Windows VM, and the Windows VM will get bare metal speeds on the actual graphics card, because you're fully passing through the physical GPU into the virtual machine. We will save that question about concurrency later on, because that was actually kind of a design decision, and there's a future enhancement that we want to do as well. And so this kind of all culminated into, all right, so we want to make the base OS more stable. We want to be able to pass through the full-size graphics cards into the virtual machine. And as Eric said, I love automation, or I'm automation obsessed. I don't even think he knew that this was in the slides. Maybe he did, but I use lots of Ansible and Vagrant in just my general day-to-day work. Ansible is a configuration management tool to provision different machines, and Vagrant is a tool to automate the creation of virtual machine, or automate the utilization of virtual machines, not the creation. That's a separate process. So that was kind of the overview of the solution for what we ended up moving forward with. So continued. Long story short, we ended up to improve the stability of the bare metal OS. We ended up falling down to Ubuntu. So that way we can make sure we always have that guarantee of making it connect to the VM or to the VPN. So that way we could always have a fallback to actually gain access to a physical machine. And then from there, we actually had the cracking operating system be a Kali VM. And I actually maintain an automated build process to where it completely builds a Kali VM in the background for me in a CI/CD job. It's been down for a little bit, but it still works. Utilizing that image still works. So essentially, in this particular VM instance, we had an MVP, or a minimum viable product, for Kali. So it's literally, I had to install SSH. It's so minimal. So it's pretty much SSH and a text editor, and then the NVIDIA drivers from that cloud cracking blog. We can answer that later as well. But yeah, so this VM was solely dedicated to only doing the cracking itself. I actually don't even install Hashcat from the repositories because we had issues, some issues with that. Not as much, but we had some issues with that in the past. So I actually I pull down Hashcat on the bare metal OS, compile the Hashcat binary, and then use that binary inside of the VM. So that way we don't even install build tools for Kali, because I didn't want to chance anything messing up with Kali. If you can tell, I'm little bit hypersensitive about Kali messing up because of all of the different maintenance issues we've had with it out in the field. But Kali is an awesome operating system in general for pen testing usage. So that was kind of the solution we ended up going with. And here is kind of a visualization of how everything fit together. Let's see, just checking the questions real quick. The deets of the stripped down Kali, yes, we have a blog post coming out that we will be sharing that information. All of this stuff that I've done is actually in Ansible collection, and so you will be able to do exactly what I have done. And I actually gave a talk at CarolinaCon as well that I showed a demo of this working. And so I can't believe I didn't think about linking that repo, but we can link that repo at the end. So that way you guys can have access to exactly how this would be set up. I just stripped out all of the secure ideas information from that presentation. So long story short, we have our own VPN that our client devices connect to, and then it's not really shown here, but there's actually a second VPN that the cracking machines would connect into as like a device-specific VPN instead of a client-specific VPN. And by client, I'm meaning consultants. So the consultants would connect to the VPN, and we do an initial provisioning or access provisioning for getting the bare metal operating system installed. It's pretty much just a plain Ubuntu 2004 or Xubuntu 2004 or 2204 installation. And once you get that bare metal OS installed, everything else happens after we've joined it to the VPN. So I take and use Ansible to provision the bare metal OS, which includes copying over the oh wow, that's someone already linked to my talk. All right then. So the bare metal OS just has very thin provisioning because, like I said, I'm remote, so I try to make it as little as possible that someone like Doug had to do, especially for Gray. And we like to have consistency through infrastructure as code, which is what Ansible does with its configuration management. So we do that provisioning, and it actually copies over a Vagrant file. And in that Vagrant file, it has all of the necessary information for passing through the GPUs to the virtual machine. And whenever it does that, it sets up the whole NFS share and everything like that. So whenever it does a Vagrant up, it creates the VM and starts binding the GPUs to everything, and also builds Hashcat. And then after that, it does some initial provisioning to join the cracking VM to the VPN network that it's connected to as well. And that's where I start to do all of the actual provisioning for the cracking VM as well. And so from there, we do the entire installation process over the span of one manual command to join the bare metal OS and then 2 playbooks. And we have an entire operating system or an entire cracking server spun up. So it's a lot more streamlined, and I've actually had Doug and Eric, who weren't involved in the process at all of doing this. We now have a web UI that they can just click a button and it launches the playbooks necessary for being able to provision bare metal server to the cracking VM. And they don't even have to know how any of this works. So it's greatly improved our stability and allowed us to actually have a lot less issues with the cracking servers. And I think the last time we had an issue with the cracking server was gray again. And that was probably 2 or 3 years ago. So it's been pretty much a non-issue ever since we moved over to this architecture. And the other thing about it being inside of a VM as well is that whenever we do upgrades, so say for whatever reason Kali does have some type of issue, I actually snapshot the VM before I do the upgrades automatically inside of its monthly upgrade playbook. And so I'll power down the VM, snapshot it, and then do all the upgrades, reboot, and then I'll run a command to make sure that all the NVIDIA stuff still works and that Hashcat still launches. And then if it doesn't, I have a notification at the end that alerts me that says that it fails. And then if it doesn't, I have another playbook to revert the VM to the last snapshot. So all of this stuff is now completely automated through Ansible playbooks. So I pretty much don't have to do any manual commands because automation is awesome. Non-issue causes it quick to rebuild, or non-issue causes it non-issue because that's a good clarification, Mr. Widget. Non-issue because it is more stable. And it's a non-issue because we have that bare metal OS, which is no longer having to deal with NVIDIA drivers and is constantly connected to the VPN. So if we do have any issues go awry in the actual VM itself, which we have had less issues, but there has been maybe 2 times over the past 2 to 3 years that it has had an issue. But at that point, I just do the revert playbook and everything goes back to how it was before. And I wait for the next month for the upgrades to go. And also a non-issue because the Kali installation is so much more minimal. So it's got a VPN, OpenSSH, and a text editor. Forgot to mention VPN before. But yeah, it's got those 3 things and that's it. That is why it is a non-issue. So that's a good point of clarification. Next slide, which actually will be interesting. This was a video. How do I play that?
Yeah, we won't be able to do the video. I mean,
okay,
we can if you want. Sorry.
That's okay. If you want, I can screen share.
Go for it.
Okay. So this is a video I recorded for Carolina Con whenever I gave that presentation. Let me find, there it is. Okay. All right. And share screen, Windows, this one, share. All All right, you guys should be able to see my screen, right?
Yes.
Cool. All right. So, yes, I will get you the link for this video. So this is actually me running the playbooks. I'm using a tool called Ansible Navigator just so that way I don't have to. It has nice visualizations for things, so that's why I use that. But you can just use regular Ansible to actually run these playbooks. So I am launching the command with the bare metal provisioning playbook, and this will actually go pretty fast because the OS was already provisioned because we didn't want to have to completely tear down a server because we were in the middle of cracking things. So this is it going through and doing the actual installation of all the bare metal OS. It should speed up rather quickly soon. Yeah, there we go. 600% speed up, so that way you guys don't have to wait for it. And so this is it actually doing the entire installation for the bare metal OS. And pulling down Hashcat from its GitHub repository, checking it out to its most recent release, compiling all of that, creating the NFS shares. Oh, that's actually one thing I hadn't talked about yet. Making sure that everything is prepared for PCIe pass-through, which is all of the IOMMU and VFIO stuff, which that can be complicated, but because I've automated all of that, you guys don't really have to even think about it. It should just handle everything for you. And if it doesn't, just create an issue on the GitHub repository. So now it's actually started the cracking VM and provisioned it for that initial VPN access. And now I am launching the process for the cracking VM host itself. 1,000 times speed up. So this part, because it was a completely fresh VM, takes a while. And so the actual download and installation of the NVIDIA GPUs by themselves probably takes about 15 minutes, which they have a gigabit connection in JAX. So it's pretty much pulling as fast as it can. Or no, they don't have gigabit. They have 500 megabits, but still, it's pretty much a non-trivial issue compared to like a residential connection. So this, you see, it's saying in progress, and I think it ends up taking like 3 to 5 minutes at minimum, and that's on a really good connection. So that's something that, 7 minutes, to be wary of if you're doing these fresh installs. Yes, so the part where it's checking if the /root is a symlink, what we actually do is we don't have a /root folder. We actually just have the /root folder. Sorry, that's not an accurate statement. We don't have a local /root folder. The /root folder is actually getting served from NFS. And that's where we keep all of our client information and stuff like that. So that way we can have a consistent rebuild of VM. So that way we have all of that stateful data staying local on the host. And then all of that gets shared directly over the network. It's just pretty much a local connection for the VM for the actual cracking machine to use. So that way it's super fast because it's local, and we can have consistent rebuilds of VMs by resharing that folder in the future. And that ends up carrying over things like bash history and other things like that as well. So there we go. Now I just connected to the VM, and you can see this is our old cracking server, so you can see that it only has 3 GPUs. But you can see that everything launched with NVIDIA, and everything's working with Hashcat. And that was based off of those 2 playbooks. Cool. Stop sharing. Okay.
No, the NFS shares are locally on the hard drive. We don't have them external. So if there's a great meltdown.
Yeah, so we have a process we're working on still implementing with replicating things that aren't client sensitive to like an S3 bucket. So that way we can keep our password cracking lists. But the NFS shares are all local, mainly for latency sensitivity perspective, because whenever you're loading a password list in that's a few gigabytes, it's not super enjoyable to have to wait for that entire password list to load. So just something to consider. If you do have a fast network, you could have it be an external machine. We just reuse the bare metal host just because it's easiest right now.
And with 3 servers, they're all sharing. I mean, they all have the same lists and things like that. So,
yep.
While they're all in the same rack, there's some redundancy.
Yeah, exactly.
Which, back to the question about concurrent cracking, Alex.
Yes. So there were many discussions before me and while I was here about how if we should try to go more density and less servers, or more servers and less density. So if we instead took our $10,000 just to build one server and we had a server case and stuff like that, one of the things we thought about was the whole the queue building up. So if we have more servers, we can point a consultant to, hey, go use this server because this server is preoccupied with cracking hashes. In theory, there's ways to do that if you you have a really dense machine and you end up slicing up the GPUs to each VM, and so that way you could have multiple hosts to still crack on. But it was just simpler from our perspective to have multiple machines so we can have multiple hashes running, but also still get very good performance for what we were paying for. So it was kind of a balance of what we are willing to spend for budget constraints versus what's practical for usage. Have you thought about doing several servers with something like Ceph and KVM to do clustering? I personally haven't. I don't have very much experience with Ceph. If I remember correctly, Ceph is ZFS back for its bricks, which is nice to have that redundancy. In this situation, we've just gone straight ext4 for the main file system. And KVM clustering is another thing I just don't have as much experience with. But in theory, as long as your network is performant enough, you could do something like that. It's just maintaining the complexity of distributed systems, i.e. Ceph, and clustering versus actual just standard or solo boards themselves. Multiple VMs. Each VM has the same spec. So the PCIe pass-through, there's one manual thing you end up having to configure. And in theory, I could automate it. I just didn't feel the need to at the time. I specify either AMD or Intel because they have different kernel values for passing through the VMs. So I set that in the inventory file for Ansible, which passes it to the correlated systems. But by doing that, I can automatically like on the fly, be able to set and configure the kernel parameters for doing the PCIe pass-through. And then at the same time, I automated the process of grabbing all of the NVIDIA graphics cards, their PCIe lanes in the Linux kernel. I automated that process by essentially just grabbing all the, almost doing like an LSPCI, and then grepping for all the NVIDIA stuff. So I grab all of that information for all the PCIe lanes and dynamically add that to the Vagrant file. So that way it's more replicable, like you can replicate it across multiple systems. So that is how I handle dynamic values for configuring the different VMs based on however their hardware is configured. So that also makes it more reproducible for other people as well. So that way it just dynamically grabs the NVIDIA stuff. So that answers the value of identical pass-through values and stuff. Why, thank you. So the SSDs versus hard drives versus NVMe. One thing to consider about for NVMe is that that actually takes up PCIe lanes. So if you are on a server that doesn't have as many PCIe lanes as you need, we didn't really have that issue in our situation, but we were looking at an AMD Threadripper, which actually only had 64 PCIe lanes. I say only, but it's still quite a lot compared to the 128 that we got with the Epic. It was like minuscule. So if you're building a system with NVMe, make sure that your CPU supports enough PCIe lanes. You could still do like a regular SATA connection for an SSD, but something to consider. And then we ended up getting an SSD for the actual storage, like a regular SATA connection, just so that way it's faster. But I think we ended up getting like a terabyte, so that way we just had some extra space. The link for that presentation/video is on the screen right now. So if you guys, which I can also put in the chat, so that way you guys have it. I've noted. Oh, wow. All right. It doesn't work with me today.
With about a minute left here or so, as you know, we see the negatives and positives here. One quick question that I'm sure people are asking is, what type of performance are we seeing from these cracking servers, right? How many hashes are we doing per whatever computation cycle you feel like choosing, a second, etc.? What were your benchmarks like?
It's a very good question that I should have had prepared. But I have it in a GitHub issue, so give me a second, because I can find it pretty quickly. But long story short, we were seeing the best performance in our configuration. So best by, okay, technically it's second best, but the amount of hash loss that we had was like 1,000 millihashes or something like that. It was very minuscule. And for us to have that extra stability and redundancy allows us to have a more resilient setup compared to if we were doing just bare metal stuff. It was more complicated from the perspective of making sure things were stable. So definitely something. We're actually going to have a blog post coming out about benchmarks specifically. So we will have a more thorough answer for everyone in a future blog post.
All right. Do you want to go over this really fast?
So, I mean, most of it's just pretty much stuff we've actually already talked about through questions and stuff. So slight performance overhead, slightly more, it's more complex than just a bare metal install, but the actual supportability is less. And then more compute that's constantly reserved because the VM is assuming that utilization. And then positives, better reliability, Helps when managing more than one server because you're doing it in an automated way and versatile. So we have created an ML VM for one of our consultants that allows him to do ML things. And all we have to do is vagrant down, and it spins down our cracking machine, and then we do a vagrant back up whenever we want to spin it back up. So it allows us to have a lot more versatility.
Great. Well, cool. So any other last minute comments here before we wrap it up? No? All right.
No, I have not seen any black vans in my
which is good.
Wait, but you're not here, so you can't see the black vans.
That's right.
DoorDash has a hard time finding us, so I'm pretty sure the NSA will too.
And there will be more details in the future blog series that we have coming out too. So stay tuned to our blog so you can find out more about that.
Yep. Cool. Well, thank you, Doug. Thank you, Alex. And thank you, everybody, for attending. If you're interested in more webcasts, Jennifer Shannon has one coming up next Wednesday, the 6th, on the Anticast, talking about radioactive vulnerabilities, how you might want to integrate some security checks into your SDLC so your problems don't become toxic and deadly later. Kevin is going to be at the AID conference in West Virginia next week. Then on March 13th, we have a webcast with Mick talking about how you can find and test all sorts of different web services on applications, even if they're not necessarily exposed. And then the 28th, we have another webcast with John Knepp and Josh Kemp talking about how all of those small, less severe vulnerabilities we have floating on our network turn into the bigger problems that people like us, when we're doing pen tests or real attackers, use to actually move through your environment. But anyways, thank you once again. Yep, death by 1,000 paper cuts, exactly. Thank you again for all attending, and we hope to see you again soon.